Hello, welcome to any community. From the past several videos, we are discussing about the concept of electrocardiogram. First, we have started with indications and contraindications of electrocardiogram. Later, this is being followed by the normal electrocardiogram. After that, we have learnt about the ECG leads. Later, we have learnt about the fundamentals of electrocardiogram. So, from the initially we have started with the indications, etc. After that, we have started with the simple informations on electrocardiogram. After that, we have started with some of the deep informations related to electrocardiogram. In today's video, we are going to discuss the application of Einthoven's triangle, how that is helpful in deriving the the axis wheel or hexaxial reference system. We are going to discuss in this particular video. And what are the significance of the hexaxial reference system, and how to draw the ventricular axis. What are the methods of drawing the ventricular axis? We are going to discuss in today's session. Hexaxial reference system is also known as axis wheel. When you think about the Einthoven's triangle, so this particular Einthoven's triangle is being derived by the principle that any electrode placed at a distance of more than 15 centimeters will have no major difference in the deflection of ECG waves. Based on that, the electrodes placed on the right arm, and left leg, they said to be present at the equidistance, forming the equilateral triangle. So this is what as this particular principle is based on the electrocardiogram. Who has invented the Einthoven is the person, or is the physiologist, has developed this particular phenomena. Though that's why it is being named as Einthoven's triangle. If you join the leads 1, 2, and 3, they are being forming the Einthoven's triangle. As it is a closed circuit, the electrical potential will be 0. With this particular information, now we are going to modify the Einthoven's triangle. Suppose if this is considered to be the small picture showing the green colored line, this is an extended image in the main diagram, wherein the center is being depicted by the purple colored ring. So this is what is considered to be the first line in the modified Einthoven's triangle. When you think about the lighting the another line, this is what we can say lead 2. That is having the, as it is an equilateral triangle, the distance between the lead 1 and lead 2 will be 60. That too, it is a plus 60 degree. If you think about the third lead, this is being modified in such a way that the positive pole of lead 3 will be situated at plus 120 degree. So this is the AVR. It is made in such a way that the positive pole of lead AVR is situated at minus 150 degree. AVL, this is being present at a distance of minus 30 degree. This is AVF, which is being situated at plus 90 degree. The main source, that is the from where we are going to calculate, that is from the lead 1, which is said to be at 0 degree. This will be the overall value whenever if you are modifying it into the Einthoven's triangle, modified Einthoven's triangle, as it is having the 6 leads, they are being termed as hexaxial reference system. Hex refers to 6 in number. And this is also being termed as axis wheel. When you think about these are the different values. So that means the lead 1 is said to be at 0 degree, lead 2 is said to be at plus 60 degree, lead 3 is said to be at plus 120 degree, lead AVR is said to be at minus 150 degree, lead AVL is said to be at minus 30 degree, and lead AVF is said to be plus 90 degree. When you think about the picture, the above circle, semicircle, is having the negative values, whereas the downward semicircle is having the positive value. As far as the information related to the hexaxial reference system, as we have discussed earlier, it is also being termed as axis wheel. This particular axis wheel places all 6 frontal plane leads, that is limb leads, that is leads 1, 2, and 3, AVR, AVL, and AVF in one picture, so that we can draw the ventricular axis or QRS axis very easily. This is also helpful in determining the other cardiac vectors also. That means atrial axis can be drawn, nodal axis also can be drawn out of this particular the hexaxial reference system. The significance of this particular axis wheel is to know about the axis deviation. To know about the right axis deviation or left axis deviation. This is what is considered to be the hexaxial reference system. When you think about it, the upper half, as such, this is considered to be negative half, whereas lower half is considered to be the positive half. Of course, it should not be confused with the positive half and negative half of the leads. Regarding the rules of hexaxial reference system, these are the following rules that one has to follow while looking into the hexaxial reference system and its usage. Positive pole of lead 1 is said to be the 0 degree of hexaxial reference system. By convention, all the values of upper half of a reference system is said to be negative half of reference system. By convention, the values which are present in the lower half of the reference system, that is being termed as positive half of reference system. As we have discussed earlier, positive as well as negative degrees of reference system should not be confused with positive and negative poles of the lead. We are going to discuss in the coming slide regarding this. As such, when you think about the nomenclature of a positive and negative half, this is actually quite irrational. Why? Because this is considered to be 360 degree. It's the axis wheel. It could have been rational if it is being started with 0 and ended with 360. But this is not being practiced. Upper half is being considered to be negative half and lower half is said to be positive half. And based on that only, the values are being kept out. And all the positive poles of the lead axis are lying between minus 32 plus 120 degree, except AVR, which is said to be present in the negative half of the hexaxial reference system. When you think about the positive and negative half of the lead, this is the one example where you can say a positive and negative half of the lead 2 in this particular example. That is it's not lead 2, it is lead 3. When you think about this particular half, which is facing towards the positive pole of the lead 3, that is said to be positive half of lead 3, whereas the other half is said to be negative half of lead 3. As far as the normal and abnormal axis are concerned, the minus 30 to plus 110 degree, if the electrical axis lies, then it is said to be minus 30 degree. Minus, that is normal electrical axis. If the axis lies between minus 30 to minus 90, then it is said to be left axis deviation. If the electrical axis lies between the plus 110 to plus or minus 180, then it is said to be right axis deviation. And the axis, if it is lying between minus 90 to plus or minus 180, then it is said to be northwest region, or otherwise it is said to be intermediate axis. It is also being termed as no man's land, because this is the one particular area where electrical axis will not be usually being present in almost all the electrocardiographic recordings. This may be present in cases of probably dextrocardia. Regarding the clinical conditions where we are going to expect left axis deviation are inferior myocardial infarction, left ventricular hypertrophy, left bundle branch block, left anterior hemiblock, and emphysema. These are the clinical conditions where we are going to expect left axis deviation. And right axis deviation, the conditions are where in case of right ventricular hypertrophy, right bundle branch block, anterolateral myocardial infarction, and left posterior hemiblock. These are the clinical conditions where we are going to expect right axis deviation. Now, how to determine the electrical axis or the ventricular axis? Basically, 3 rules are there. Among that, we have to identify the which area we are going to have the electrical axis. The rule 1 says you have to, first of all, you have to identify the equiphasic, the deflection, in which particular lead we are going to see the equiphasic deflection. The term equiphasic refers to, it will be having both positive as well as negative deflection. If you add these two deflections, the summation will be 0. And we are going to concentrate on the frontal plane leads only. That is 1, 2, and 3, AVR, AVL, and AVF. We are going to see those frontal plane leads only. Whenever if you see that the equiphasic deflection, it is the first step. The second step is we have to identify the perpendicular leads towards that particular lead. So here, when you think about the image, it is being said to be the lead 2 that can be almost equal to 0. That means the positive and negative pole of lead 2 is being calculated, that will be becoming 0. So that means electrical axis will be perpendicular to lead 2. This is what we can say the electrical axis. This one, this particular lead is having the electrical axis, that is having the equiphasic deflection. So that means it will be perpendicular to that particular lead only. In that particular sense, this is the image that is considered to be See this is perpendicular to lead 2. So that means the adjacent leads will be AVL we have to look into, as well as lead 3 we have to look into. So that means the electrical axis the may be either having the blue line or having the pink line. So that means when you see these two leads, the electrical axis is moving towards AVL itself. That means it is towards the upper half, that is the 2 towards AVL side. The value of lead AVL is minus 30. That means the electrical axis of this particular example is the minus 30. But when you think about the lead 3, that is showing the negative deflection. So that means electrical axis is not towards the pink line, that is towards the blue line. So that means in this particular ECG strip, it will be minus 30. When you think about the electrical axis in this particular example, which is the you're going to see. The example here, again, it is lead 3 is having the electrical axis, right? So that means the electrical axis in this particular example, it is not the lead 3, it is AVR. AVR in the sense the electrical axis will be perpendicular to lead AVR. The adjacent leads that we have to look into is lead 3 as well as AVL. When you see about the lead 3, it is having the prominent positive deflection. That means electrical axis is moving towards lead 3. Whereas if you see the lead AVL, it is having the prominent negative deflection. When you think about this, electrical axis is moving towards the lead 3. As the value is considered to be the minus 150 minus 90 means what? Electrical axis will be towards it is plus 120. So that means as the electrical axis is lying between the plus 110 to plus or minus 180, electrical axis considered of this particular example is said to be having the right axis deviation. In this particular example, which is the electrical axis that will be almost having the equiphasic deflection, again it is lead 2. When you think about that, electrical axis will be perpendicular to lead 2. The adjacent leads that we need to look into are AVL and lead 3. That means when you see the electrical axis, lead 3 is having the prominent negative deflection and AVL is having prominent positive deflection. That means electrical axis or ventricular axis in this particular ECG strip will be towards lead AVL, and the value of lead AVL is minus 30. That means the electrical axis is within normal range. In this particular example, say this, it is the lead 3 that is having equiphasic deflection. That means the perpendicular leads which are considered to be for lead 3 are AVR and lead 2. And when you see the lead 2, there is prominent positive deflection, and AVR, there is prominent negative deflection. That means electrical axis is moving towards lead 2, not AVR. So that means the rule 1 says we have to, first of all, we have to identify the equiphasic deflection. When this equiphasic deflection is seen in any particular lead, that is indicative of electrical axis will be perpendicular to that particular lead. So that means the second step that you need to follow is to identify the nearest leads which are perpendicular to that particular lead which is having the equiphasic deflection, and look into the deflections on those two leads. The positive deflection will not be present in all those two leads. In one lead there will be positive deflection, and in another lead there will be negative deflection. So that means, so electrical axis will be moving towards the upward or positive deflection of the perpendicular leads to that particular equiphasic deflection lead. So that means in this particular example, it is the positive deflection is in the lead 2. Hence, the electrical axis of this particular example will be plus 30. Why? Because the positioning of lead 3 is plus 120. When you think about the minus, that means subtracting the value 90, it will be becoming plus 30. In this particular example, see the electrical axis. It is again the lead 2 is having the almost equiphasic deflection. That means it will be perpendicular to lead 2 we have to see. So that means the electrical axis of this particular example will be minus 30. When you think about the second rule, we have to identify the two adjacent leads in the given ECG strip that will be considered to be exactly identical. In that particular sense, this particular rule says the electrical axis will be midway between those two leads which are having equal configuration of a QRS complex. When you think about this particular smaller image, 1 and AVL, they are having almost equal QRS complex. So that means the electrical axis will be lying midway between the 1 and AVL. So the positioning of lead 1 is said to be 0, and positioning of lead AVL is said to be minus 30. That means the electrical axis will be passing midway between the 0 and minus 30. That is, electrical axis of this particular example will be minus 15. Look into this particular example. That is, here rule 2 can be applied. When you see the value lead 2 and lead 3, they are having equal QRS complexes. As they are having the negative deflection, electrical axis will be moving the exact opposite direction. The value of lead 2 is plus 60 and the value of lead 3 is plus 120. So that means the electrical axis is passing midway between the lead 2 and lead 3. And when you think about the deflections, they are negative. So that means it is exactly moving in the reverse direction of lead 2 and lead 3. That means it is the minus 90 will be the electrical axis of this particular example. So that means it is a left axis deviation. When you think about the rule 3, this can be applied to any of the electrical axis. So that means we have to identify the algebraic sum of any two frontal plane leads. We can take 1 and 2, we can take 1 and 3, we can take 1 and ABR, we can take 1 and ABL, and we can take 1 and ABF. Or we can take any of the two frontal plane leads only. Based on that, we have to make the algebraic sum of electrical deflections, and that has to be jotted down in the hexaxial reference system. So in this particular small inset image, the lead 1 is having the 10 mm deflection, whereas lead 3 is having minus 10 mm deflection. That has to be depicted in the hexaxial reference system. Suppose if this is the plus 10, so that means this particular example, it is the plus 10 is there. We have to jot it down. Whereas in the lead 3, it is minus 10. This is considered to be the positive half of lead 3. This is considered to be negative half of lead 3. That's why we have jotted down at the minus 10. We have to draw the perpendiculars. So that will be meeting at one particular point. So from the center of the hexaxial reference system, we have to draw a straight line that will be giving us the electrical axis by making the angle with 0 degree. So here it will be considered to be the value is, that is, minus 30. So this is an example where rule 3 only can be applied. When you think about it, here we have taken rule lead 2 and lead 3. Lead 2 is having almost 5 minus 10. And lead 3 is having 15 minus 15. So that has been drawn, and from that will be meeting at one particular place after making the perpendiculars. To the meeting point, we have to draw the line from the center of the hexaxial reference system. That will be giving us the value by taking that particular line with the lead 1. So here it is more than minus 60. That means it is in the left axis deviation. In this particular example, only rule 3 can be applied. The reason is here we are having only lead 1 and AVR. So the value of lead 1 is 5 plus 3 plus 8. And AVR is having the value 4 plus 5, 9 plus 11. That is minus 11. So we have to draw the perpendiculars from the lead 1 and AVR. If that is being made, this will be the depiction, and that will be meeting at that particular point. From the center of the hexagon reference system, we have to draw the line which will be meeting at the meeting points of perpendiculars, and we have to see the angle from lead 1. It is up to something around 40, that is plus 40 degrees we can get. So these are the different examples that we have drawn based on the hexaxial reference system. How that can be used. So the take-home messages from today's discussion are: hexaxial reference system, that is also being termed as axis wheel, which is derived from Einthoven's triangle in a modified form. Only frontal plane leads are being taken to do the analysis of ventricular axis, or this can be applied to assess atrial axis and nodal axis also. The normal range of ventricular axis lies between -30 to +110 degrees. If the ventricular axis lying between the +110 to ±180 degree, then it is said to be right axis deviation. And if the electrical axis lies between -30 to -90, then it is said to be left axis deviation. And the examples for the right axis deviation, what we can say, that is right ventricular hypertrophy, right bundle branch block, etc. Whereas the examples for the left axis deviation are left ventricular hypertrophy, etc. can be given. Dear ANA community, that's all for today. What are the major key takeaways from today's discussion? Mention in the comment box below. And what is the one video that you would like to hear in the coming days? Mention in the comment box below and spread this particular video to maximum number of true Ayurveda learners or true Nidana learners. We can make a huge movement out of this particular small message. That's all for today. Something more in the next video. Thank you.